Hello everybody, today I'm going to show you a proportional voltage calculation in a series circuit. If you look at my circuit, it's just a series circuit. I've got R1, 2, and 3. R1 is 5 ohms, 2 is 10 ohms, 3 is 15 ohms. In this case, I've set a voltage of 90 volts. And to solve this in a traditional way, what we would do is look for our total. So 5 plus 10 plus 15 would give us 30 ohms over here. 90 divided by 30 would give us 3 amps. And then because in a series circuit, I total equals I1 equals I2 equals I3, etc., we could take that 3 amps and put it into each one of our T's for this circuit, which would give us 15 volts there, 30 volts there, and 45 volts there. So since I is equal throughout this circuit, the value of the current is the same at each resistor is what we're seeing here. So if the value of R in any one of these resistors goes up, then the value of E also goes up. And we saw that here. So a 5 ohm resistor is 15 volts, where a 15 ohm resistor is 3 times as much, or 45 volts. Now, what we can do is build an equivalent T for these two. And in this case, we would add the resistance, which would give us 25 ohms of resistance. The current through there would be the same. And so we'd end up with 3 amps. 25 times 3 is 75 volts. And you can see that 45 plus 30 is 75 volts. So we can add the 25 or add the two resistances and use it with the total voltage of those two resistances. We can also look at R1 in that way. So R1, if we look at the amount of resistance, which was 5 ohms in R1, the total resistance in the circuit was 30 ohms. And this is going to be the proportional calculation. So 5 out of 30 is 5/30th, or when we divide that out, it's 0.166. And if we times that by 100, we would end up with 16.6% of the voltage will fall across R1. And if we take that, we knew that 90 volts was our total times 0.166, and we will end up with that 15 volts. I can also do that with R2. So R2 was 10 ohms out of a total of 30 ohms, and that will give us 10 out of 30 is 0.33 times 100 equals 33%, actually 33.3% is the percentage of the voltage that will drop across R2. So 90 volts times 0.333 gives us that 30 volts. And we could do the same for R3, and we would end up with R3 equals 15 ohms out of a total of 30, which will be 15/30th is 0.5 times 100. 50% of the voltage will drop across. So 90 times 0.5 equals 45 volts across R3. So it's just a different way of looking at the series circuit and calculating them out. We did it the traditional way where we added all of the resistances, found I. We also used two of the resistances, so the value of two resistances and the voltage of those two resistances, we could calculate back and find the amps, or using proportional method, we can find each one based on the percentage of resistance out of the total resistance. So I hope that was helpful, and we'll catch up with you again. Thanks.